Chapter 2.1, we're looking at transformations of quadratic functions. Now, the beginning of a chapter always has a lot of vocabulary. And so let's take a look at what we have in this chapter. We have quadratic functions, a function that can be written in the form f of x equals a times x minus h squared plus k, and a cannot be 0. If a was 0 in this case, it would make this all be 0, and then it would be a different type of function. So that's why it has that there. Parabolas. Parabolas are the U-shaped graph of a quadratic function. So if you did the other example, we have our parabolas. Vertex is here, and we can go use the pattern right one, up 3, and then it's reflected across the axis of symmetry. So parabolas are the U-shaped graph. Now, vertex form, the one we're focusing on, is the one I mentioned above, f of x equals a times x minus h squared plus k. So the a in the front, if there's a negative in it, there's going to be a reflection in the x-axis, or it can also represent a vertical stretch or shrink with these numbers here. H indicates here a horizontal translation, so it means moves either right or left. K at the end, that indicates a vertical translation up or down. Now the vertex, to talk about some of the language here. The lowest point on a parabola is one that opens up. Okay, so if you think about a parabola here, so I'll graph it, the lowest point is this point here, right? That's the absolute lowest point on the parabola. Then the highest point, so if we have a parabola that opens down, for example, the highest point is here. So that's when it opens down. Now what I want to get practice in is to identify vertex and axis of symmetry from vertex form. So identify vertex and the axis of symmetry from vertex form. So remember, vertex form looks like this. So we're getting lots of practice in writing that because it's really important to try to remember. So the h here is our x value of the vertex. It is also called the axis of symmetry. The k is the y value of the vertex. So our vertex is hk. So that's why it's called vertex form. You can read the vertex quickly in this form. Now, one thing to note is that there's a negative in front of the h. So that's why, for instance, when you see a -3, that's actually right 3, right? So it's a positive 3. So the h is always the opposite sign. The k will be the same. So let's do an example here, finding vertex and axis of symmetry from vertex form. So in this first example, all we need to find is the vertex. The vertex is the h and the k here. So h and k. And then note that -1, so I said it was supposed to be opposite. So what should that be here on the right? That should be a +1. And then the k value stays the same as a +4. Now the axis of symmetry, it's always an x equals, because it's a vertical line. In this case, it is always the same thing as the x value of the vertex. So it's x equals 1. So try the rest out. So remember h and k, what h and k represent, which one needs to be opposite, and then what represents the axis of symmetry. So pause the video and try these out. All right, so hopefully you tried this out, so you easily identified or quickly identified the vertex and the axis of symmetry. So the vertex, again, just look at the h and k. The h has to be opposite, so therefore this is +4, 3. Axis of symmetry is at x equals 4. So make sure you do write x equals 4. If you just write 4, that doesn't tell me enough information. Then this one is -5, +2. This is +5, -3. And then this is -2, -1 here. And then you can write the axis of symmetry from that vertex. Now let's take a look at different types of transformation. So again, just getting more review on transformations. It's very similar to our absolute value. Now we are going to get practice in graphing quadratics, and for now we're going to use the pattern as much as possible. So let's do reflections over the x-axis. So we notice, number 1, that this is +a. This one's negative. So let's just draw the parent function +x squared here. X squared. So remember with that it starts at 0, 0, and then the pattern is right 1, up 1, right 1, up 3, and then left 1, up 1, left 1, up 3. And then so here is just +x squared. Now, if it's reflected, it's going to open down. So therefore, it's going to be here And instead of opening up, we're going to go right 1, right 1, down 3, left 1, down 1, left 1, down 3, and here is the graph. Now, just to kind of, if you're still not sure where these numbers are coming from, you can always plug in points into this x squared. So I'm going to do a table here, x and y, and we're plugging it into x squared. Now, I'm going to do 0, 1, 2, -1, and -2. So we plug in 0 into this equation. 0 squared is 0. And then if we plug in 1 to 1 squared, what's 1 squared? 1 squared is a +1. If we plug in 2 squared is a +4. 2 times 2 is 4. Then -1, so just to be careful, -1 squared, right? If you have this here, you plug it in exactly with the x. So in this case, this is -1 squared, which is still a +1. -2 squared is a +4. So let's graph these points. 0, 0 is here. If we graphed 1, 1, so right 1, up 1, it's right there. And then here, if we plugged in 2, we would get a 4. It is always in this pattern. And notice it goes in the same direction here. So it's always, when it's just an x squared with no value in front, it's always going to use that pattern of 1, 3, 5. Now, if you have an a value in the front, what you do is you're going to multiply that, and we'll see that later on. Now, reflection over the y-axis. Now, in this case, I'm going to use something different just so you can see what it looks like. Notice that we have x equals a times y squared. Now, this isn't a function, but I just want to show you what this looks like. So this is a sideways parabola. So a times y squared looks like this. So just as an example. And then when it reflects over the y, right? So notice there's a negative in front here. It's going to flip on the other side. So this is a reflection in the y-axis. So notice it flipped over this way. Let's look at this example, vertical stretch and shrink. So 3 times x squared. So what happens here is that we were actually multiplying, and this is going to be a vertical stretch by 3. Okay, it's greater than 1. Now, I'm just going to do a little table to plug this in. So we're plugging in 3x squared. And then what do we get? So I'm going to do 0, 1, and -1 and +1 here. So if we plug in 0, 3 times 0 squared, that's just going to be 0. Now 3 times 1 squared, so 1 squared is 1, and so this is going to be 3. And then on the left, 3 times -1 squared, so the -1 is squared, so that ends up being 3 times 1, which is still +3. And then if I go one more out, let's just try 2, just so you can see it. So it's 3 times 2 squared, and then so that's 3 times 4, which is 12. So it goes up very, very quickly. So we start at 0, 0, and then at 1, we're at +3. And then at -1, we're still at +3. It's going up very, very fast. And then the next point is 12. And so what I want you to notice, so number 1, if we apply the pattern 1, 3, 5, we have an a value of 3. We can multiply it. 3 times 1 is 3. 3 times 3 is 9. 3 times 5 is 15. So what happens here is that we're still using the pattern. We're going to go right 1, then we're going to go up 3, right 1, up 9, right 1, up 15. So let me show you. Here it's right 1, up 3, right 1, up 9. Think about it. 9 plus 3 is 12. And so it really does work with that pattern. Okay, so now this one. This one's a little tough. We have y 1/2 times x squared. So one way to think about this is we want to plug in a number that multiplies nicely to the x squared. So what number will be good here? Any multiples of 2 would be wonderful. Now let's just try 2. I'm going to try x equals 2 and see what happens. So we get 2 squared. So that's 2 squared, which is 4 over 2. 4 over 2 is 2. I plugged in a 2, I get a 2 back. So it is right 2, up 2 here. If I plugged in a negative 2, it would still be the same. So this is 1/2 times x squared. You kind of have to plug in numbers. There are some shortcuts to this as well. So this is a vertical shrink by a half. Okay, vertical shrink by a half. Now, kind of as a hint, when you have a fraction like this, really what we can do is you pick whatever that denominator is, and you're going to get that same value back. So 1 over a, you choose the a, you're going to get that same value, a. So you move right a, up a from the vertex. Now I'm going to show you with, say, 1 over 5. 1 over 5x squared. We're going to choose a 5, right? Whatever the denominator is. If I choose 5 and I square it, 5 squared is 25 over 5. 25 over 5 is 5. So notice I plugged into the denominator. I get that same answer back. So to graph, I just want to show you this. If I graph 1/5 x squared here, I would go right 5, up 5, left 5, up 5, and that is the graph. It always tends to be that direction there.